Alright, let's see. So, we got a lesson today, 3.2, day 2 and day 3 on your little notes packet. On Friday, for y'all that are in class, I'm not going to be here, so there's going to be a video on YouTube that I need to record at some point before Friday. For y'all, there'll just be one lesson, the 3.2 day 4. It's on outliers. And also there is our first major grade is due on Friday, and you can work on that whenever you please. It's the Unit 1 progress check on College Board. So got those as well. And then when I see y'all again next Tuesday, we have some homework and a quiz due. And we're also going to chunk some tigers off of the crosswalk down to the cafeteria. Yeah. Alright, so that's our plan. Going for that. And yes. Okay, so what we're going to do is today we're going to talk about residual plots, standard deviation with the least squares regression line, and a value called r squared, or coefficient of determination is the mathematical word for it. But let's just go over some stuff real quick that we've talked about so far. So we've got scatter plots. We talked about those are quantitative variables, like you've got height and weight, or age and height, whatever you've got graphed with the dots. How to describe them is, there we go, you've got DUFS is the acronym that we use. So D is for direction, and you've got like positive or negative direction, or kind of no direction, I guess, if it's just a blob.
Is there like another letter that would go with the U? Because I remember seeing it somewhere as something different.
Maybe it was just O for outliers.
That's what it is.
Yeah, because that's what U means, like unusual feature. So for the most part, you're talking about like an outlier, or is there just something that's kind of sticking out? Which for the most part is like, hey, is there some outlier that's like really far away, above our data, way to the right of our data, whatever. Your F is your form. And so when we're talking about form, all that is just linear, or is it some sort of non-linear? And you could just say non-linear, but that's like exponential, or is it quadratic, or whatever. Square, you could have a square root, whatever. Does it have some sort of curve, basically, that's not, or is it just clustered in certain spots, or does it seem like it has some sort of linear pattern? And then S is strength. And do y'all remember how we calculated strength?
How close it is to 1 and -1?
Okay, how close what is?
The R.
Yeah, our R value. So R is our correlation. And then, yeah, so it is basically -1 to +1. -1 would be perfectly negative, and then +1 would be perfectly positive line. And as you're approaching that, and there's some limits to R. R is only giving you the value of how linear it is. It doesn't tell you how good your curved data is. It only tells you how linear, and it gives you direction. It's not affected by changing units, or there's some other stuff. I think that's good. Then the last time I saw y'all after the quiz, we talked about residual slope and y-intercept, and we talked about the prediction line, all that good stuff. So do y'all remember, someone remember a residual?
Is it like the one?
Yeah, I kind of see that. You've got like you've got your line of best fit, or your least squares regression line.
How far away
It was
it
how
And then-
far away from the...
Yeah, so like maybe here's my actual values, and yeah, so a residual is here's my predicted x, here's my actual, how far from predicted y to actual y. predicted to actual, and the prediction line is cutting through there somewhere. And so the main screw up with residuals is not getting it positive or negative right. So if you draw yourself a picture, and here's my actual, and there's my predicted, I can see that that is a positive residual, and this one would be a negative residual. So that's kind of a spot where people get messed up. What is the interpretation of slope?
That's the relationship, like how.
It's talking about rise or run, it is a relationship, but it's like what is, like if I had a slope, if I had a slope like this, like y equals 2x, and technically be y hat, like what does that 2 mean?
Each predicted value goes up, like,
Yeah.
I guess.
Like
goes
each
up.
time that the x, or the y increase the x goes up by that.
It'd be every time I go
Or every
1
time-
up with the x, and specifically always mention like 1x. So like every time I go one value up in the x, I go 2, my predicted value goes 2 up in the y. And so we talked about using the word predicted. We're always using for our predicted y, our predicted x. Because we're not knowing the actual, we might not know it. So yeah, for every 1x, I would go up 2, my predicted y value would go up 2, positive 2, or it would increase 2, something with a positive value. The y-intercept is sometimes appropriate, sometimes not, like we talked about. So the y-intercept is when x equals 0, that's our predicted y value. But if I gave you a line with like the weight of a car and the miles per gallon, the y-intercept doesn't make any sense, because like if I had a car that weighed 0 pounds, it has a 50 miles per gallon like fuel efficiency. It's like there's no car that weighs 0 miles per gallon. So the y-intercept is just when x equals 0, this is our predicted y, the y-intercept. Okay, so that was kind of our last day. That was our first little unit. We talked about correlation. Okay, so what we're going to do today is we're going to talk about residuals again here at first, and then the second half we're going to talk about standard deviation and R squared. Alright, so this first page here, 1 through 8, is again, y'all are going to use it by doing the stafflet. So someone in your group or both of y'all can kind of go through it. We're going to go to stafflet, and we're going to put in our units in the stafflet and follow 1 through 8. So try that out. 1 through 8.
I need to get a doctor's note for my car. Can you tell me when the best time is for me to run up there and grab it? Like when we're not doing like birth teaching or something.
Yeah, I guess technically, no, you wouldn't miss out on any teacher.
My car's like right in the front part.
Okay.
Do you park in the back lot?
Alright, so 1 through 8, go on to Stafflet, and we're inputting our data. You're looking at the scatter plot, and then you're talking about some different things. Like number 2 is the form. Then we do predictions. We're making a residual. So follow through these things, try it out on your own, and then we'll kind of go through it and talk through some stuff. Have access. Is there a way for me to pause this video?
I know, I think we could go in order.
Alright. Guess there's no way for me to pause. I'll try to pause the video. So love chocolate.
It's not linear.
Welcome.
The boys team is good. The girls team, we had 4 girls for the last meet.
Instead of a team of 7.
Instead of 7 plus JV, just 4 varsity girls. So we don't have very many girls, but the guys are good.
Wow. Sometimes you can't help it. There's not enough.
Yeah, a lot of people quit when our own coach left.
Yeah, it's kind of hard to have some turnover.
Yeah, but like, I don't know, I feel like they didn't give him a chance. And he's really cool. He's got a lot of fun. I mean, my computer's dead,
Trying to look
so I'm trying to charge my computer.
Let me see how much battery I have. I don't know either. I think I'm gonna have like a little bit. Like more dots.
Yeah.
R equals 9.
I see, I had an iPhone 5.
That's not even on the battery.
I had a yellow one. It was yellow. It was as yellow as that poster up there, like that
what?
color.
The equation, how we're not being connected.
Now iPhone's
Y
taken over the
equals
world.
1.6 X.
Now this number's probably at like.
I did not have a
100.
yellow. I did not have a yellow.
Never know.
Mine is what? 3.22?
Let's see, iPhone.
32.
Or Apple, Google, Amazon. Running the country.
Probably true.
And then Elon Musk by himself.
Just trying to get off this planet, that's all he's doing.
I was on one of those like military commercials, and I saw like all of like the listings, like different branches. One of them is Space Force now.
Yes.
I'm like, that's very tempting. I want to be a Jedi.
Not quite, I think.
I feel like
You never know with Elon Musk.
I said linear. I don't know. It kind of, I don't know. It could be, I don't know. I'm gonna say the curve. Actually, yeah.
It's kinda like-
Cause it's kinda like going like that. Yeah. But I don't know if it looks like those stupid things that like, with like, the little like line that you're supposed to do it. I hate math. I hate math. Oh yeah, I was forced into this class.
I honestly liked math up until this year. I think that my other classes were so fun.
I really was. I really.
Yeah, that, no, or I can't tell which one, there you go, the bottom 2 points. Yeah, okay, I just couldn't tell. That thing is like pointing to stuff above.
Yeah, that was
Did you
You
draw?
should be able to just type in like stuff like you into your phone.
How'd you do that?
You don't have to work.
The line.
There's a link in school with you, but it should just be able to go.
Oh yeah.
Oh, did you just write it down?
Oh, there you go.
Oh, I was confused. Did you not really do it?
Well, I guess I can.
You know what I realized this year? That I thought that I could possibly be alive in 2000, but it would be 2100. I don't know, like 100 years from now is 2100.
I do. I'm gonna get it right now.
Like that's 1,000 years. Like I realized that
And
this
you
month.
never know, you know, you could make it to 6,000.
Well, like I had that realization like a year ago, but then someone was talking about it this morning. She's like, you know what I figured out? And I was like, yes, you can. And I was like, wait, no, you
Is it
can't.
It'd be 1,000 years old.
Oh.
I'll write it down. For
Oh.
you. I had to look at it. I had to look at it on longer. I didn't.
I thought you were talking about the next question, 'cause I'm on that one.
My brain doesn't work. Right. Wow. 25.
Not fun. Nobody knows what they're doing. She's like mad at us because we have our rough drafts like really bad.
Is it your, the I area?
I don't know what it's supposed to say. I guess that's what it is.
Yeah, we have an essay.
Yeah, we have 2 presentations and then
It's fun. We can do it at church.
If you could, yeah, it's just, nobody knows what I'm like. It's really confusing. But it's a way, she said that only one person is available to mine, so I'm like, I know. I was good until I got here. You said good one. And I got confused. I don't know.
Yeah. What do you get?
Well, okay, this, like, oh, okay. I think I know what it is.
So, you
I
did
did 2 times.
0.3222 times 0.6, but that's 3222.6.
Okay, yeah.
You did times, so you
Okay,
did some.
yeah.
You did some.
I just entered it wrong.
Yeah.
How far are we going?
8.
Oh, I'm kind of confused.
Alright.
So what's the?
That would just be like if you put in a prediction for what it was, but I'm fine with just using this to see the residuals. Cause that's it, like if you did the prediction, if you plugged it into that for all of these, that's what you would write, if you did it by hand.
That makes sense.
So technically you could get it by just doing like what and what minus that to get that one, but
It's fine. Okay, I'll do that. I checked the calculation number. I don't know.
if you're getting to like number 5, on the Staplet, there is a little spot, like if you're, once you calculate the least squares regression line, it like pops up a graph of some residuals like this.
I really was up there.
So like this is what that residual plot is on number 5. And we're going to talk about it. So you could also do it by hand, but so yeah, like on number 5 as well, you should be able to hover. So like you could calculate each of these by hand, but like you could also hover over the little year, the dot, and it says like the year 2007, the residual is 1.898. The year 2008, the residual is 0.793. Just a little helpful hint there if you didn't see it. So it kind of gives you the residuals on each of those.
It's a positive.
So you did calculate the quadratic. Be the discrete set. There we go.
Shut up, you're
I really prefer these.
Alright, let's talk through this. Let's go for it. So on number 1, create the scatter plot. Year is the explanatory, and the unit sold is the response. So remember, explanatory versus response is like, we're trying to see, like, the response is our outcome, and so like our outcome is like how many more are kind of being sold each year. That's why the sold, so our sold versus year. Describe the form. To me, it's looking like the form is linear or nonlinear, and I just said distribution looks nonlinear to me. So to me, that looks like it's kind of like flat line, and then all of a sudden we're really boosting up there to all of a sudden 5, 10. We're like doubling almost every 2 years. Yeah, it looks kind of non-linear to me. Number 3, use the applet to find the least squares regression line, which once you click on the applet, it gives you that least squares regression line is it's a line of best fit. So those are kind of the same when you're interchangeable to each other. So kind of the best line that you could put there. So write the equation below. So I'm just going to write it up here. So you go to Staplet, and the Staplet one had like a massive amount of decimals to it. I think I rounded to like 3. But yeah, so there's our equation, and it gives us an S and an R squared, which we're going to talk about. And then there's that line. Let's see. You had y hat, and it was like 3,200, negative 3,200. So y hat equals negative 3,222 dot, I just said 633. It is important that you're putting like y hat, or you could put the unit sold hat. Like you could just write what the y variable is. And then it is plus 1 point, and I just went with 3 decimals again, 605x. So for every year added. So that's our line of best fit, our least squares regression line. And yeah, so this is what we're going to use to predict. So then you should have used that number on 4 to then plug in. So you plug into negative 322 plus 1.605, and then you plug in 2007 into your x. And I got like negative 1.39 or it was 3898, something like that. So I just went with like 0.4 because the 8 would round to 9, up to a 10 to make that other one 9. So it's kind of stumbled into a rounding all the way to 1 decimal. You could have written it 3 decimals, either way. So negative 1.40, and what value is that? Or, yeah, it's a negative, wait, yeah, that's so weird. So we're predicting negative 1.4 million units sold is how bad our least squares regression line is for that predicted line. Because let's just look at this graph real quick. Let's look at our Staplet. Our Staplet is like the line to best fit it had to include this here to where at 2007 it was predicting negative units sold, which makes absolutely no sense for this part. And so maybe we're got something weird happening here, which I think we do, which is kind of the point of this. But we have negative 1.4. That's what we're predicting for units sold. It's negative 1.4. The question here was, let's interpret what is the residual. So our picture of it is, here's my line of best fit, and at 2007 I'm predicting negative 1.4 million units sold, and we got on our thing, our original iPhone sold 0.5 million. So this is our residual. What is the distance between those two? So you do 500,000 minus negative 1.4 million, and our residual, that little distance there, is 1.9 million. And then is it positive or negative? Well, our actual value is above the line, so that's a positive 1.9 million residual. So our actual point was 1.9 million units above our predicted line. So looking at that. Okay, complete the table on number 5. So if I kind of come over to the computer, you've got, for the table wise, I would have just, you could do it all by hand, but that would take a little bit. So you can kind of hover over these and kind of see where these residuals were. And you should have, when you do that, so this one, like we did this one, it was negative 1.4 million, and we got positive 1.9. I think the residual on the paper went all the way to 3 decimals. It was probably like 1.8 something because they didn't round like we did. But they had a residual at positive 1.9. So I'm going to graph these as we go on this residual plot. So this is kind of our main thing for the day is we have residuals, and then we can make a plot of residuals. And what this is like our y-axis is all of our residuals, and our x-axis is our variables. So if you have a residual of 0, if you were equal to the predicted line, you're going to be on here. But instead, we are up above. So if I kind of come up here, or I already did it right here. Here we go. So here's my predicted line, and I'm just going to make a graph. Instead of it being on a slant, now that predicted line is now my 0 residual. So that's what this line is right here. It's just flat. So right here kind of. And now these residuals kind of come in and they just go vertically up or down. So it kind of just puts all the residuals into one little spot. So like on 2008, I got a residual, I just rounded to 2 decimals on all these. of 0.79. So that would be like there. Which I can't remember. On the Staplet, I think they went to 3 decimals on all these. Yeah, 793. And so here is that value. And so where they're getting that, again, is it is this distance right there. So we're converting this residual into just kind of a flat line graph of where our residuals are. So this positive residual is that same distance right there. This next one looks like it's going to be a negative residual, and so you can see at 2009 there's a negative. It goes into the negatives on our residual. So it's just putting these just into a flat, like, were you even to it, or were you above or below? Okay, so let me fill out the rest of this on our paper. So let's see, I got, for the next one, I got negative 0.81, which I just showed you on the Staplet. And on your line of best fit, that number is below the line of best fit, so it has a, or the least squares regression line, so it is below, it's a negative residual. Okay, then you got negative 1.72, so it's about down here. You've got negative 1.02, so it's about right there. Negative 1.63 at 2012. Positive 0.77. So somewhere above again. And 0.16. So at 2014, we were really close to almost having our prediction and our actual be perfect, like the same residual. And then 2015, we were 1.56 above our prediction here. So we were up above again. Okay, so this, the residual plot doesn't tell me if the graph is like negative or positive. It does tell me though, are values missing high or low or high, where are they at? And so if I kind of erase this little part, like just from looking at this, if you told me it was a positive distribution, I could draw a positive line, and then I know I have a couple points above, I have 4 points that then come below, and then I have like 3 more to kind of finish above. So I could just look at this and plot myself some sort of distribution. If it's negative, it would just be a negative, and I have some above, some below, some above. Okay, so for which of the points was the actual greater than the predicted? Which of them were less than predicted? So these values here were the ones that have a actual or greater than predicted. So I just said our actual value was above prediction. So that's just saying that our actual value was above. And then we have this group of 4 was where our actual value was less than predicted. Just looking at a residual plot. So it just takes, it's not a graph, it's not a scatter plot. So this is a whole different thing. It's, you take your scatter plot, you calculate residuals, and then you have a 0 residual, and you just plot them above or below. Yes, sir?
Can you fill out the table? I'm kind of confused on the predictors.
On the what?
The predictors?
Like you're
Good.
not watching those?
On this part?
Yeah, can you show us how to calculate it?
Okay, so this would just be like, for 2008, you would come up to this equation and plug in 2008 right there.
So you get like 10 or something.
Y'all didn't get negative 1.4 there?
I got something weird.
It wasn't like from 2008, it was like 10.
Like mine was all wonky.
A bigger number than.
Like,
Maybe you need to check if you plugged it in, right, on the equation.
I know I got a number.
I think I did. I didn't like.
Cause like, I mean, I did it, and I got that first one. So let's see, negative
Which equation?
I got
322.633. So you come here, we're on our Staplet, and you're using negative 3,222.632 plus 1.605 times 2008, and you get 0.207. So I think if you're not getting those values, you're just your calculator.
I was doing it on my.
Oh, did you reset?
phone.
Oh, on your phone. Okay, well, it doesn't quite. The phone can have some mistakes, and then you can't see what you plugged in. So, yeah. So I mean, you just plug into this equation. So if you're getting some big numbers, then it just may be plugged in on your phone wrong. Okay, so I got our prediction line. Okay, so this last part, do you think the regression line is a good fit for the data? So do you think that our line of best fit, that straight line, is a good fit for this data? Why or why not? And then we're gonna do it using residual plot. So just looking at this, going back to the Staplet, and from our first prediction here, I don't think it's a very good line because, for one, it had like negative 1.4. We were kind of seeing something weird from the beginning. But what we have when we do a residual is that my residual plot, it's not good on a residual plot when there's a pattern. And there's a clear pattern to our residuals. Some go above, and then we go below, and then we go above. There's like a curvature to our residual. And what that means, why that's bad, if I scroll up, yep, it screwed it up. But if I scroll up here, I had some that are above, some that are below, and some that are above. Like, I think that just means a straight line was not our best line that we should use here. Like, in reality, I think this data is not linear. So like, number 2, what form did you think it was? Me having kind of some residuals above, and then below, and then above again is kind of showing that I kind of probably have a curved, more either exponential or quadratic. It could be something, we just don't know what type it is, but it's definitely, it seems like it's not really fitting a linear pattern because there's kind of some wonkiness happening. And so an easy way to do that is, or a nice way that the residual plot is, if the residual plot is kind of showing a pattern of like up and down like this is saying that it's not really hitting through the middle of our data very well. If I had a good residual plot, so kind of a good residual plot would look like this, where I have a 0 residual, and I have some that miss high and some that miss low, and it's all throughout. It like misses high and low consistently. Because what this graph would look like, it would be some sort of distribution where some are high, some are low, some are high, and it's got a good mixture throughout. So this would lead me to say that I have a good, like, the line is actually going through my data nicely. if it's got a good spread of above and below there. If it has a distribution where there's a lot above and then there's a lot below and then there's a lot above again, it's got some sort of curve happening. So we don't like that. So it would say it's not linear. So do you think the regression line is a good fit for the data? I would say no, because, and then you could talk about how the line kind of, your prediction in 2007 was negative, or just the main thing here is the residual plot showed a pattern, and that's not good. We don't want the residual plot. So no, because residual plot had a pattern. Data seems curved. Like, or you could say non-linear, whichever. So our residual plot, if it's a good plot, it will have an even mixture throughout. Because if it's fitting a straight line, so kind of coming back here, if it's fitting a straight line nicely, your line of best fit will cut evenly through the whole time. So it will have an even mix of positive residuals and negative, positive, negative, positive, negative. So that would mean our residual plot would look something like this, like no real pattern to it, just a nice above and below. So calculating these, it's just, that's our predicted line, and it's how far, it's just a plot of each and every residual for the entire graph. So yeah, if we're wanting linear data, it should cut nicely through it. If I have some sort of like exponential, or I guess this would be more, this would maybe be starting to be quadratic or something like that. If I made a line of best fit through here, it would look something like this, and I would have some negative residuals, a whole bunch of positive ones, and then some negative ones. So that would not be a good residual plot. So yeah, the residual plot is really just turning this graph flat, and it's seeing positive, negative. Okay, so that's kind of the main idea. So if you were on like the backside or whatever, the big idea here is like residual plot. Yeah, you can go back. The residual plot, we want, you kind of had a good versus bad. So a good, and I guess I should put the word up here. So a residual plot is just a graph of all of the data's residuals for a linear plot. So if it's good, I'm going to have an even mixture. And maybe you'll have some, but then like it'll at least be somewhat mixed through there. Like maybe it's not perfect, but an even mixture. So good would be like even mixture of positive and negative residuals. A bad one shows a pattern. So if you have any sort of pattern, it's not a good thing. So bad would be, you can see a pattern. So an example like we just did would be you have some above, some below, and then you come back above again. That would not be good. And then sometimes they've even talked about this one, where you have a little bit of data here at the beginning, and it's evenly mixed, but then all of a sudden it becomes like kind of cone shaped like this. Even that is not a good, that shows me that this is not a good scatter plot for linear data, even if it has this sort of cone shape. And let me try and make a scatter plot from that. So like, let's say I had a positive, what this would look like would be, I would have some here, and then, let's see, it would look something, the graph would look something like this, basically. And so maybe, basically the data is so spread out that this, we don't really know if it's linear or not. So any sort of pattern that you see in your residual plot is not good. We want there to be a nice even flow throughout of the same. Okay, so a residual and then a residual plot. Alright. Okay, so on this one, maybe I'll walk through this one real quick. I'm just gonna put this one into Staplet. Oops.